Welcome to and all for this today's session. Today we are going to discuss about the subject composites, materials and structures, unit number 2. The topic is micro and macro mechanics. In this today we are going to deeply talk about the micromechanics approach of materials and the key aspects and what are the techniques used in this and what are the applications in the micromechanics materials approach. First, we should know what is a micromechanics. Micromechanics of material approach involves analyzing the behavior of materials at the micro scale, considering the interactions between the individual grains, phases, or particles. This approach helps to understand the material's overall properties and behavior. And then the key aspects of the micromechanics materials approach. They are grain structure, phase distribution, particle reinforcement. Next one is micro crack propagation and dislocation of dynamics, interface mechanics, micromechanical modeling. These are the key aspects in the grain structure. Here we are going to understand the arrangement, shape and the size of the grains in polycrystalline materials. And in the phase distribution, we are going to analyze the distribution and the interaction of different phases in multi-phase materials. Under the particle reinforcement, here we are going to examine the role of particles of fibers in composite materials. Under micro crack propagation, it is nothing but here we are going to study about the growth and the interaction of micro crack in the materials. Under dislocation dynamics, here investigation of the movement and interaction of dislocations in the crystalline materials will be done. Under interface mechanics, to understand the behavior of interfaces between different phases of particles will be carried out. Under micromechanical modeling, here to develop the models to simulate the behavior of materials at the microscale level. These are all the key aspects of the micromechanics of materials approach. Then the techniques used in the micromechanics of materials are one is called a TEM, that is a transmission electronic microscopy. Next one is scanning electron microscopy, is a familiar one. FEM images are doing to be done, and X-ray diffraction (XRD) analysis will be done. Then micro indentation. The next one is finite element modeling (FEM). It is a very important phenomena of the techniques used in the micromechanics of materials. In the transmission electronic microscopy, high resolution imaging of microstructures will be investigated. And in the scanning, same images, imaging of surface morphology and microstructures can be done. In the XRD, that is X-ray diffraction, here analysis of crystal structure and phase distribution will be carried out. In micro indentation, here measuring of the mechanical properties at the micro scale level will be done. In the finite element modeling, here simulating the micromechanical behavior using numerical methods will be done. And the applications point of view, one is the materials design, failure analysis, property prediction, optimization, and then multi-scale modeling. In the materials design, developing new materials while with the tailored properties will be done. Then failure analysis, here understanding the material failure mechanisms. Then predicting material properties based on microstructure is called a property prediction. Optimizing the material processing and the properties is called optimization. Linking micromechanics to the macro scale level of the material behavior is called multi-scale modeling. These are the applications of micromechanics. Then in detail, we should know about the grain structure. Under the grain structure, we should have a grain size and the grain shape, grain boundary characteristics, grain orientation and texture. These are the two approaches have to be discussed here. In the phase distribution, phase morphology, there is a shape, size distribution, and a phase fraction, that is a volume percentage, phase boundaries and interfaces. Next one is particle reinforcement. Here, particle size, then shape distribution, particle matrix, interface characteristics in the composite materials, particle reinforcement mechanisms, that is a load transfer to the composite material, and crack bridging will be studied here. Then micro crack propagation, that is called crack in intimation. Okay, that is a crack initiation of the growth of composite materials. Crack microstructure interactions, that is a crack grain boundary interactions, crack shielding and bridging mechanisms. And the dislocation dynamics, the things to be studied are dislocation types, edge, screw, mixed type, dislocation mobility and interactions, dislocation grain, boundary interaction. Then the interface mechanics here. Another thing is to be focused here. Interface characteristics, that is strength, toughness, adhesion. These are the properties, material properties have to be analyzed very well here. And the interface microstructure interactions has to be done. Interface failure mechanism to be analyzed in the interface mechanics. Then micromechanical modeling. Here, what we have said earlier, finite element modeling, boundary element modeling, then analytical models. These are the things will be coming under the approach of a micromechanical modeling. And applications, materials design and optimization, failure analysis and prediction, property prediction and estimation, material selection and substitution, multi-scale modeling and simulation. Then I've already dealt those things called techniques, that is transmission electron microscopy, scanning electron microscopy, X-ray diffraction, micro indentation and nano indentation, finite element modeling, computational material science, it's called CMS. Those are the techniques available for the microscopic level approach. And what are the challenges and the limitations in this microscale level approach to be seen here? Experimental challenges, that is like the sample preparation, imaging resolution are the very important challenges in the microscale approach. Modeling limitations are also a challenge, like assumptions to be taken for as well as simplifications for getting the solution. Is also a great challenge or a limitation to be considered for micro level approach. And scalability and the transferability of results also, integration with the macro scale material behavior. So these are the challenges and the limitations to be done. Okay, actually these are the microscale level approach are very much important, as well as researchers and engineers can develop more accurate models, predict material behavior, and design new raw materials. So these are the things today we have discussed. Once again, I will summarize those things. What we have done. First of all, micromechanics. What is a micromechanics, and what are the key aspects coming under the micromechanics of materials approach, and the techniques used in the micromechanics of materials approach. Then applications of micromechanics materials approach. So these things we have studied in the previous class. We will see another topic in the next class. So thank you for watching this video. Thank you and all.